Bezant and Zhu looked at this, and they said, well, you have to have half the columns fail about the same time. There's 47 steel, huge, 3 feet at the base, steel columns going up the core. 47, they're interconnected. How do you get them to fail simultaneously so the core disappears? In the FEMA report, they said, well, if you look at the videos, that tower, this antenna tower, drops before the rest of the building starts to collapse. And I looked at the data too. It does. It drops about a dozen feet before, which is, quite a drop. And then things start happening down below where the plane went in. But the plane did not cut all those core columns. The building stood for quite a while, so it's not like it was just ready to tip over or something, which is what you'd expect, by the way, if you cut some on the side. It looks like those core columns were pulled, cut. The support was gone from the core first, and that is the way demolitions typically proceed.
A 50-plus story section of the North Tower core remains standing after the collapse. This is what you would expect from the pancake theory. But watch what happens next. The core does not tip over, rather it collapses down upon itself, as if the entire structure had been cut. You can even see gray smoke rising from the end of the steel.
Now what can do that? What can move mass out of the way? Explosives. Explosives cut those steel support columns, and they can also then, up above as there's explosives, produce dust.
There were fires of 2,000 degrees Fahrenheit below the ground. I could be standing here and you could be standing there, and I could be describing to you, Governor, the site, and then a fire would break out in between us. And it was just by luck or the design of God that we weren't killed.
I started looking at the molten metal, you see. And to me, Mike, this is one area that had not been researched much before. All 3 buildings, both towers in the rubble, in the basement areas, and Building 7, there's these pools of molten metal.
This is how it's been since day one. Oh, it's unbelievable. And this is 6 weeks later, almost 6 weeks later. And as we get closer to the center of this, it gets hotter and hotter. It's probably 1,500 degrees. We've had some small windows into what we thought was the core at some point, and it looked like an oven. It was just roaring inside. And it's just a bright reddish orange color. See that stuff he's pulling out? What was that, Chief? We're gonna hold off on the water. See the stuff he's pulling out? Yeah. It's red hot. If we hit it too much steam, you won't be able to see what he's doing. Great.
So I'm looking through the official reports. What do they say about the molten metal? They say nothing. But wait a minute. This is important evidence. It's discussed by many people. Initially on the scene, you have people saying the molten metal is flowing down off the rubble. It's flowing down into these gigantic pools of molten metal now. I mean, it's flowing. It's not like it just formed somehow after the fact with fires, but it's molten right just very shortly after. And still flowing off. So where'd that come from? Not from fires. We agree on that. Where did it come from? The only explanation I can find for that is exothermic chemical reactions. And the most notable suspect is a thermite reaction. It doesn't have to be thermite. There are other high temperature chemical reactions, but that's the most likely one. Thermite can be purchased on eBay, and many people, I show it in my class, physics, and I'll be showing it this fall in my physical science class. What we've got is a mixture of iron oxide, which provides the oxygen, and aluminum powder. A lot of that dust is aluminum oxide. You form aluminum oxide and molten iron. That's what the molten iron looks like. Notice the color there. It's a yellow-white hot, which would be easily 1,000 centigrade. It's around 2,500 Fahrenheit or so. It requires the oxide. It's the oxygen here that's held by the iron that allows this to go. And as we bump these together now, you'll have a reaction in which the aluminum picks up, steals the oxygen from the iron oxide, and the aluminum just grabs on that oxygen and produces a very high temperature reaction. And the result is jet fuel will not ignite that. That's one thing. But you get it to ignite with an arc, for example, or burning magnesium. It will ignite. This is just kind of a fun way to show on a small scale. The products are molten iron. Remember, all three buildings had molten metal. And aluminum oxide, which goes off primarily as a dust. You know those enormous dust clouds? You can imagine when you assemble these chemicals on a large scale, the amount of heat that you generate. People say, well, if there's explosives or something, okay, you've got your arguments, but where's the smoking gun? By analyzing this, we determined it is not molten aluminum from the plane, okay. Indeed, it contains a great deal of iron, which is the product of the thermite reaction. It's not just structural steel that somehow melted, no. It's very little chromium. But it does have sulfur and manganese and some other elements that are characteristic, you see. It's like a fingerprint that the criminal left behind. This carries with it evidence. How was this done? What was used? And I should explain real quickly. This particular, people ask me all the time, where'd you get this? Well, there's a woman, she read my paper. I'm calling for an investigation, particularly of this molten metal, and see what's going on. She immediately sent me this sample from this memorial to 9/11 and to the families, who I deeply sympathize with those families. So we checked this metal, and that's how we got it. And another sample like it, same characteristics, high in iron, manganese, fluorine.
The FEMA report acknowledges recovering 2 structural members with unusual erosion patterns in the World Trade Center debris field. Appendix C of the report looks at a limited metallurgical examination of these samples done by Jonathan Barnett, Ronald Biederman, and R.D. Sisson Jr. Here are their findings. Both samples contain significant levels of iron oxide and sulfur. The thinning of the steel occurred by a high-temperature corrosion due to a combination of oxidation and sulfidation. The sulfidation attack of steel grain boundaries accelerated the corrosion and erosion of the steel. In their suggestions for future research, FEMA acknowledges the severe corrosion and subsequent erosion of samples 1 and 2 are a very unusual event. No clear explanation for the source of the sulfur has been identified. A detailed study into the mechanisms of this phenomenon is needed to determine what risk, if any, is presented to existing steel structures exposed to severe and long-burning fires.
NBC's Pat Dawson is close to the scene of that attack. Pat,
moments ago, I spoke to the chief of safety for the New York City Fire Department. Chief Albert Turry told me that he received word of the possibility of a secondary device, that is another bomb going off. He tried to get his men out as quickly as he could, but he said that there was another explosion which took place. And then an hour after the first hit here, with the first crash that took place, he said, there was another explosion that took place in one of the towers here. So obviously, according to his theory, he thinks that there were actually devices that were planted in the building.
Shortly after 9/11, the New York Fire Department recorded over 500 oral histories in which firefighters and emergency medical workers recounted their experiences of that day. Mayor Bloomberg's administration refused to release these oral histories. But the New York Times, joined by several families of the 9/11 victims, filed suit. And after a very long process, the city was ordered by the New York Court of Appeals to release these oral histories. The Times then made these oral histories available. These oral histories contain many dozens of testimonies that speak of explosions and related phenomena characteristic of controlled demolition.